In this video, I'm going to show you how to do a batch of simulations in Ngspice where we repeat an analysis for different pseudo-random configurations of a circuit to do Monte Carlo analysis, and how to export each of those to a text file that you can then import into some other tool for analysis. So this is a very simple circuit. What I've done is I've created, let's see, it's in Documents, MC Toot, and I've created an inverter. So here is our inverter, and I have in here my MC switch parameter, and I've set it to 1 so that the transistors in the inverter will be will have the mismatch parameters turned on. And I've prepared a control block here, and I just want to kind of go over the control block a little bit. So first of all, I'm going to set up these variables, which are basically Booleans. So set, one of these built-in variable names without a value, basically sets it to true. And so I want to set WR underscore vec names, which is going to put out in a text file, it's going to put out the column headings with the vector names. And I'm going to put the scale, which is the thing that we're sweeping, in the first column only, as opposed to repeating it for every vector that gets written out. In this case, we're only putting out one column, but I think it's helpful just to have a single scale. So I set these two things as a matter of course here. We're going to do 10 runs, and so I'm setting up a variable called MC runs and making its value 10. Then we have a run counter, which we're going to set equal to 1. And then we're going to just have a little do while loop here. So it's do while run less than or equal to MC runs. We're going to do a DC sweep. So we're going to sweep V in from 0 to 1.8 in 10 millivolt increments. So it's going to do a DC sweep. And then we're going to use a WR data command to write out the output, the resulting output voltage, to a file, and we're going to embed the run number in the file name. So this little in curly braces here, $& run takes the value of the numerical variable run and inserts it in here as a string. And so we're going to write out the data to a file that's in the directory, as the same directory as my schematic file. If I didn't put this path in here and just put the file name, it would go into ~.xschem/simulation. So if I want to put it in the same directory as my schematic, then I'm explicitly putting the path name in here. And then reset. So reset is important because reset basically resets the circuit to its initial state. And in our case here, that basically means that it's going to get a new random set of parameters for transistors. So on the next time we do a DC analysis, it's going to have a different set of transistor parameters for both the NMOS and the PMOS transistors. We bump the run index up by 1, and then we end the loop. And we could put quit down here if we wanted to, but we're just going to drop it out into the interactive Ngspice prompt, and we'll see what the plots look like, and then we'll see what the data files look like. And I'll show you an example of bringing them into a Python environment that I have set up here. But you could bring them into MATLAB or whatever else you like for analysis. Okay, so that's the idea. Obviously, you can set the number of runs higher. You could do a different kind of analysis. You can use this sort of template for doing lots of different kinds of analyses. So we're going to do netlist, and then we're going to simulate. there are our batch of simulations. And if I do set plot to see what we have here, we have 10 DC simulations. And if I wanted to plot them in Ngspice, I could use the dc1.v of v out, dc2.v of v out to put them on the same plot. So if I wanted to do that, for instance, I could go set plot new to make a new plot, and then I could plot dc1.v of v out, dc2.v of v out, dc3.v of v out, dc4.v of v out, dc5.v of v out, dc6.v of v of v out, dc7.v of v out, dc8.v of v out, dc9, dc10, v of v out. And there we have our 10 voltage transfer curves with slight variations. Okay, so that's kind of a tedious way of plotting the data. So I'm going to quit and maybe I'll bring up a new terminal window here. Let me see, toot. And so you can see I have all of these text files here. And if I like, I can look at, let's see, inverter1.txt. You can see we have here this column, which is called v sweep. That's the input voltage that we're sweeping. And we have v of v out as the output voltage. And so I'm gonna just import these into a little Python environment that I have and that I basically have made for analyzing data and things like that. And I have a little function here. So there's my v out and there's my v underscore sweep. I'm going to call v in, v underscore sweep, say v out equals empty list v out dot append v out. And now I'm going to load number 2, load number 3, 4, 5, 6, 7, 8, 9, and 10. So now I have here V out, which is a list of 10 NumPy arrays. Each NumPy array contains one of the voltage transfer curves. V in is just my NumPy array. And I can at this point delete v sweep and v out just to tidy things up a bit. And if I like, I can plot v in comma v out, and if I do that, I get my 10 voltage transfer characteristics. And if I like, I can zoom in and whatnot. So, obviously you could write a little Python script that goes through in a loop and loads inserts the number into the file name and does that all programmatically instead of having to use the up arrow and whatnot to make it a whole lot less tedious and a lot less typing, but you get the idea. So you could, for instance, if you wanted to know what the gain of this was or where the VM parameter is, you could do all that sort of analysis very easily, and then you could plot a histogram or something like that, showing statistics for whatever specification or parameter you want, and so there you have it. Thanks for watching.